questions from the ratios, conversions, and rates. So let's see the first question. For every $3 Marisa spends, Andy spent $5. So then, if I know that Andy spends $120 more than Marisa does, how much exactly does Andy spend? So first of all, I know a ratio that every $3 Marisa spent, Andy spent 5. So the ratio between two spends are 3 versus 5. Right? So let's see the first way. Remember that we can, even though we only know the relative ratio between the two quantity, we can still consider them as 3 shares versus 5 shares for 3 units versus 5 units. And based on the ratio, we know that Andy spends more than Marisa. So Andy, how much more than Marisa? So Andy spends 5 units more than Marisa, even though I don't know, right? Because I only know the relative ratio. This can be any multiple of n to the same ratio, 3 versus 5. But I know Andy has 5 minus 3 more than Marisa to spend. And then I know the extra dollar amount, even though I don't know how much Andy spent, I don't know how much Marisa spent, but I know the difference. So the difference is $120. So that means this multiple n is 120 divided by 2, which is 60. So then I know that Marisa spent 3 shares multiplied by n is 180, and Andy spent 5 times n, which is 300, right? And then their difference is 120. Right? So this is one way. By understanding the ratio and knows that the ratio is proportional to any multiple of n. The second way, you can still try to solve this in a equation. Right? For example, if I assume Andy spent X dollar, then I know Andy spent 120 more than Marisa. So Marisa spent X minus 120, right? Because Andy spends 120 more. So I know the two quantities and I know the ratio. The ratio Marisa versus Andy is 3 versus 5, 3 over 5. And then this you can solve, there's only one unknown, x, can cross product the equation, solve the only unknown variable, which is x. Two x is 600, so x is 300. So Andy spends $300. Get the same answer with the first option. Okay, let's see the second question. So I have 4 partners in a business, and they decide to split the profit in the ratio of 2 versus 3 versus 3 versus 5. So I have 4 quantities right now. So it's a multi-way ratio with 4 terms, 2, 3, 3, and 5. And I know the total profit is $26,000. So what is the largest amount that received by 4 of the partners? So it looks like this person who get the 5 shares of the profit will receive the largest amount, but how much exactly in terms of the dollar? Right, again, I know the ratio, and I know that even though they're not exact quantities, they're relative quantities, but they are proportional to a ratio of x. So this time let me assume that the actual ratio is x times the quantity. So then the total profit right? Even though I don't know the value of x yet, but I can express the total quantity of the profit into 2 shares plus 3 plus 3 plus 5 shares. And I know the total should equal to 26,000, right? So from here, I know that this is 13, x equal to 26,000, x is 2,000. So I know that each share, x, is 2,000. So then the largest amount that can be received is the person who got 5 shares. So then 5x will be 5 times 2,000, and that is 10,000. So that's the answer. Okay, let's see the next question. Dale travels from city A to city B and then to city C, eventually go back to city A. So there's ABC 3 cities. Each city is 120 miles from each other, and Dale travels from city A to B and B to C and C to A in 3 different rates or different speed. So what is the average rate or the average speed? So, right, if we have 3 cities, first travel from A to B, the speed is 60 mile per hour. Then B to C is 40 miles per hour. And then C back to A is 24 miles per hour. Right, so I have I traveled 3 segments under actually equal distance, 120 miles, 120 miles, under 3 different pace or 3 different speed. So what is my average? So the average rate can be calculated by, remember, speed is distance divided by time, right? So the total distance, because I have 3 segments, over the total time, because I'm traveling, well, Dale is traveling under different speed within each segment. So segment number 1, let's say, well, t number 1 between A and B, the time is equal to distance between A and B divided by the speed or the rate between A and B, right? So the distance, we know that it's 120 miles, and the speed, we know it's 60 miles per hour, right? Remember, the better keep the units together with the calculation, so you see that the miles will be cancelled out, hours will go back to the top, so eventually the unit is in terms of hours. That is the unit per time. So it's 120 over 60 hours, so that's just 2 hours. So have the time between the first segments. Similarly, time between BC is the distance 120 miles over the speed between this segment, which is 40 miles per hour. So it's 3 hours. And then the last segment from C to A, that is again 120 miles. That's the same, the equal distance. This time the speed is 24 miles per hour. So 120 divided by 24 is actually 5. So it's 5 hours. Right, so now I have the time spent in each segment. So altogether, that's the total time spent. So the total distance is 120 times 3, right? I'm traveling 3 segments. Each segment has this equal size of the distance, 120. And then my total time span will be the sum of the 3 segments. So it's 2 plus 3 plus 5 hours. So my unit would still be miles per hour, right? And then this is 360 over 10 miles per hour. So simplifying this, get 36 miles per hour. Right, so that is the average speed for the total travel. Okay, next, if I have a ratio that 4 versus x squared equal to x versus 16, what is the value of x? First of all, observing this question, we have an unknown variable x, we have an equation. Seems like we are going to solve a equation, but this is not a linear equation because you have a term with x squared. So this is beyond what we have learned by how to solving the linear equation. Of course, in the future, if you know how to solve the nonlinear equation, you're still able to solve it as a equation. But here, let me show you another way that you don't have to really solve it from the equation. You can observing the question and to see the pattern. Because I have one ratio is 4 versus x squared. The other ratio is x versus 16, right? So then the second term, 16, is actually a complete square of 4, right? 16 is 4 squared. And then by observing the other part component of the ratio 4 compared to x, you can identify the solution right away, because when x equal to 4, it satisfies that 4 equals to 4 and 4 squared equals to 16. So this question is really just asking you to observing what you had here and to without solving the equation, by finding the solution of this one. Okay, let's take a look at the last question. The last question, we have buses travels between Dallas and Houston. And we know that, let's draw the picture here, from between Dallas to Houston. So the bus departs from Dallas, leaves every hour on the hours. That means the buses travel eastbound from Dallas to Houston, leaves at every rounded hour, for example, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock. And then buses from Houston to Dallas also leave every hour, but on the half hours. So basically, buses travel this Houston bound. For example, they leave at 7:30, 8:30, 9:30, and go on. Okay, and assume that they traveling on the same highway under the same speed. So every single bus travels or spends 5 hours to complete the travel either way. So it's 5 hours travel. Now, assume there's a bus or any bus departs from Houston. Houston, that's called Houston bound bus. When Houston bound bus travels this way, there's many Dallas bound buses already departs or in the middle of the road, or will be departs during this traveling. So for the complete 5 hours traveling, how many buses departs from Dallas bound will this bus meet in the middle of the road, in the middle of the way? Okay, so first of all, we need to know, you can imagine that here, every hour I will have one bus on the road, and it spans 5 hours till the end. So if we only consider the buses departs from Dallas, and assume that right now it's 8 o'clock in the morning, for example, then I can segment the whole distance by hours, right? Because eventually spend 5 hours for a Dallas bound bus reach Houston. So if I'm at 8 a.m., there is a bus prepare to depart. That means an hour ago, the 7 a.m. bus has already departed for 1 hour, right? And then it's in the middle of the way. And that means there's another bus who departs at 6 a.m. also on the way and is 2 hours apart from Dallas. And if you keep going, you have 5 a.m. bus locates over here. You have the 4 a.m. bus locates here in the 4 hour apart. And eventually the 3 a.m. bus has just arrived at Houston, right? So basically, if I'm looking at the scenario at 8 o'clock, I have this many buses with one bus right in the departure point, one bus just arrived, and 4 other buses in the middle of the way at different locations, hour by hour, because Dallas bound bus departs every hour on the hour. Okay. Similarly, Houston bus departs every half hour, every hour on the half hour. Right, so then Houston bus would be at 8 a.m. Your 7:30 bus has just departed half hour, so it's a half hour away from Houston, right? And then 6:30 bus also on the way and halfway between the 3 and 4 hours. Then you have 5:30 bus is here, 4:30 bus is here, 3:30 bus is here, right? So this time you have 5 buses on the way at each corresponding location. Now let's give so those are the patterns of the bus and their locations at a certain point of time. Now time is moving, right? Because if I start counting one given bus to see how many buses it's going to meet, it's now not in a specific point of time, but for a 5 hours long journey, right? So it's not one single time point. It's a 5 hour interval. Now, because Houston bus or Houston bound bus departs at the half hour, so then let me assume that at 8:30, you can assume any bus. Here, I would use 8:30 bus as the benchmark. Okay, so at 8:30, I'm having a bus prepared to go. So at 8:30, this point of time, 8 o'clock bus from Dallas bound has already departs half hour, right? If right now the clock is at 8:30, that means your 8 o'clock Houston bound bus will travels half hour already. So the 8 a.m. Dallas bound bus is over here, right? Because it's 8:30. And correspondingly, your 7 a.m. Dallas bound bus is here, 6 a.m. Dallas bus, 5 a.m., 4 a.m. So I'm using the cross to represent the Dallas bound buses, right? So which means at the beginning of the 8:30, at the time of 8:30, there are already 5 buses on the way, right? So which means if you start traveling this way, and all such buses will travel that way, you will at least meet those 5 buses, right? And then as time goes by, as you are traveling, you need to spend 5 hours for the total journey. So which means during your traveling, there will be buses keep standing, right? So the next time I'm looking at should be 8:30 plus 5 hours. That'd be 13:30. Right? Because 13:30 is my 8:30 bus arrives. Okay, that's 13:30. Now, at 13:30, how many Dallas buses are there? It's already past 13 o'clock, so which means there will be a 13 o'clock bus over here. It departs at 13 o'clock, so it's already departs half hour. And it will definitely be met by my Houston bus, because when I'm arrived here, you traveled from Dallas half hour over here, we'll still met halfway. And this is actually the last bus I met on the way, because as of 13:30, I have arrived Dallas. There's no more bus I'm going to meet. So this is your 13 o'clock bus here. And then this is your 12 o'clock bus. You will also meet that on the way. And then this is 11 o'clock bus, 10 o'clock bus, and 9 o'clock bus. Right? So which means I have 2 snapshots of the time, 8:30 and 13:30. So 8:30, the first bus I met from Dallas bound is the 4 a.m. bus. And the last bus from Dallas bound I meet is the 13 p.m. bus. Right, so those are all the buses I meet. So then Dallas bound bus departs every hour. So between 4 o'clock to 13 o'clock, how many buses are there? Right, 10 buses. You can even just count them one by one, right? 1, 2, 3, 4, 5, 8, and 9. It's just happen to be all on my plots. So it's exactly these 10 buses, or you can mathematically solving this by 13. How many numbers between 4 and 13? That's 10 numbers. So 10 hours also representing 10 buses. So there will be 10 buses that the Houston bound bus will meet or will pass during the way. Okay, so that's the last question for this practice.